Welcome back. In this class, we will begin discussion on scalar and vector quantity. In our previous class, we discussed everything about fundamental units, unit conversions, as well as derived unit. And you have seen measuring device as well as what they measure. In this class, we will progress with scalar and vector quantity. With this note tree that you see on the screen, on board, you can see physical quantity. There are two types, scalar and vector. This is vector here, this is vector here, this is scalar here. So therefore, we say that scalar quantity, they are physical quantity that has magnitude but no direction, but vector are physical quantity that has both magnitude and direction. So this table here shows the differences between scalar and vector quantity. You can write down this and try to commit them into your hand and see what they are. Quantity, what the scalar quantity is vector quantity, and we can see from this place what scalar and vector quantity are all about. If you look at this board, you can see that scalar quantity has only magnitude but no direction. What about vector? Vector has both magnitude and direction. We are still going to look at the example and explain more about scalar. Scalar actually means value or quantity. Every scalar quantity is one-dimensional, but vector quantity can be one, two, can be any dimensional. Any change in scalar quantity is reflection of change in magnitude. Any change in vector quantity can reflect either change in direction or change in magnitude because it has both magnitude and direction, so both of them can change. Scalar quantity cannot be resolved as it has exactly value regardless of direction, but vector quantity can be resolved into several directions. So therefore, we also have any mathematical operation carried out among two or more scalar quantity provides scalar only. Results, but any operation can result in either, can result either in scalar or vector quantity. The dot product on it, that is give us the scalar, but gross product that gives us vector. Although for YX students, we are not going to look into dot and gross product analysis. Is for only UTME students. So few examples of scalar quantity are length. Example of scalar quantity are length, mass, energy, density, and anything that is potential, electric potential, magnetic has anything potential. Example of vector quantity are displacement. So we are going to see the list. So this is the list of vector and scalar quantity. This is scalar, this is vector. So you can write the list down and try to know them one by one. So what do we call vector? No, we know that we have said that we have scalar and we have vector. But scalar is just only quantity. Look at, for example, this is time. Can we say that 5 o'clock in northeast? It's not possible. Can we say that 5 kilograms in southwest? It's not possible. If it is 5 kilograms in southwest, what will it be in northeast? So this is what we call something that we can report with only value alone, without pointing to where it is going. Are you getting me now? But we can say something is displaced along east, velocity along south. We can say something is accelerated along this particular direction. So we said that we cannot teach this to your O level. We teach it to you tell me, and we said that for example, the example of vector quantity are these. So we are talking about list of vector quantity. Well, these are all vector quantity because we cannot imply their direction. These are all scalar quantity. These are all scalar quantity because we cannot imply their direction. These are all vector quantity because we can imply their direction. Now, this is vector. Vector, what is a vector? Although vector is a physical quantity, it has both magnitude and direction, right? But in real life, how does vector actually appears? Vector we can say that vector is something that we can actually grab or we can actually see, but it's something that we do. especially when you are traveling, when you are moving towards a particular direction. You tend to move in a straight line, you then tend to change direction, move in another direction. So therefore, we are trying to see the way we can represent vector so that you can view it as something that is actually something you can actually touch. That's the reason why we represent vector in form of a straight line. Vector is represented in form of straight line. Are you getting me now? Now, being a straight line, it has two regions, the tail, where something is coming from, and the head, where something is going to. So therefore, this straight line can be coded as this coordinate, and it can be also coded as this coordinate number. So that is to say, any group of vertical line enclosed in a bracket like this is actually a vector. The order of that number starts from x, y, z, depending on the number of dimension. This is a 2-dimension, this is a 3-dimension. But this is, look at this, we say that a vector can be represented with what? X coordinate, y coordinate. Example is this, 5 and 6. This is a vector that has 5 as x coordinate and minus 6 as y coordinate. This is the 3-dimension version of this one. Are you getting me? Now, we can also represent our vector in form of ijk notation. Example is this, 5i minus 8j, where k is equal to 0. So therefore, basically, a vector is represented by straight line. But this straight line, we can code it as this. Are you getting me now? Or this. So anyone that you see, just believe that you will be able to transform them into a straight line, something like this. But I must let you know that vector, what can we do to vector? We are going to see it. Now, let us now look at our vector. This is a straight line vector. This is where the vector is coming from. This is the initial point or the tail. We call it tail, or where the vector is coming from, or source. Okay? This is the head where the vector is going to. I get me. They call it sense about. We call it the length of the vector. The length of the vector. How long is the vector? Is the magnitude of the vector, and the direction that the vector faces is called its own direction. In order to know the direction of the vector, you need to identify the tail and put 4 cardinal points on that tail. If you put 4 cardinal points on that tail, the vector will be on a particular location in a particular quadrant on that 4 cardinal points. This is north, this is east, this is south, this is west. If you combine the 4 letters together, it gives you news. It gives you news with positive, positive, negative, negative. Do you see that? So the north is along the positive, the east is along the positive, the south is along the negative, the west is along the negative. So you can say that this vector here, it is along the direction of what? Northeast. Are you getting me? So by drawing 4 cardinal points on the tail of the vector, you will know where the vector is actually going to. So because vector is represented by straight line, we need to identify the types of straight line that we have. We have vertical one, we have positively vertical, we have negatively vertical, we have positively horizontal, we have negatively horizontal, we have positively slant, we have negatively slant. So, and you know that the basic principle is that whenever you want to know the direction that the vector is facing, identify the tail and draw the 4 cardinal points. This one is facing south. Identify the tail, draw the 4 cardinal points. This one is facing the north. Identify the tail and draw the 4 cardinal points. This one is facing the west. Identify the tail and draw 4 cardinal points. This one is facing the east. Identify the tail and draw 4 cardinal points. This one is facing what? Northeast. Identify the tail and draw 4 cardinal points. This one is facing west, south. So other can face any direction. So to know the component of the slant vector, append 4 cardinal points. So the same thing to the tail. append 4 cardinal points to the tail. Okay, so this is what we have carried out, and we have done it, and we are seeing how that is very, very important. We have types of vector. We have null vector. Null vector is a vector that has magnitude of 0. Position vector, vector that starts from the origin. Please, this type of vector and their interpretation is very, very important. Position vector is a vector that starts from origin. Null vector has magnitude of 0. Free vector has the free vector is a vector that starts from anywhere but origin. Starting from anywhere but origin. It can start from anywhere but not origin. Are you getting me? That's our free vector. You can now see the difference between position vector and free vector. What is unit vector? A unit vector has magnitude of 1. Equal vector is the two vector that is equal in both magnitude and direction. If any one of them is not equal, it's not a equal vector. Opposite vector, two vectors that are equal in magnitude but face opposite direction. That's what we call opposite vector. So therefore, we need to see the application of vector in real life. We are talking about vector versus scalar. We know that scalar quantity is a number with units. Are you getting me now? It's a magnitude. That is a number. It's a magnitude. Magnitude means number, okay? So we have vector, both have magnitude and direction. Now, look at this thing and look at what is written here. How to get to library. You need to know how far and which way. So let me magnify this aspect so that we can see what I'm trying to talk about. Look at this thing. There is a library here. There is a library here. There is a library here. So this is somebody, you. This is you. And you are at this point, you want to go to the library. You need to know how far is the library and where is the library. Where is the library will tell you the direction, and how far is the library will tell you the magnitude. And how far is the library is the length of the line of the vector that you are going to travel through. This is how vector is applicable in real life. Now, this is some question. Which of these following quantity are scalar? You need to know which one is scalar. I, electrical potential, torque, moment, kinetic energy. Which one do you think are scalar? The scalar is what? Electrical potential as well as kinetic energy, which is what? 1 and 4 only, which is option D. I told you that anything that is potential in nature is actually a scalar. Are you getting me? Which of these following is a set of vector? Look at the one that they are all vector. Because mass is air, mass is not a vector. Moment, yes. Because mass is air, mass is not a vector. So therefore, acceleration, velocity, and moment are actually vector, which is correct answer B. Which of the following is not a vector? Force, altitude, weight, displacement, acceleration. So altitude is not a vector. Altitude is a scalar quantity. So this is the point that we are going to be stopping here. In the next class, we'll progress to operation of vector. We are going to look at a single line vector, progressing to 2-line vector, progressing to multiple line vector. And we are going to see the principle that is applicable as we go from 1-line vector to 2-line vector to multiple line vector. Thank you for listening. ABP.